All right, so in Goal 6.5, we are going to apply and use synthetic division along with something called the rational zero theorem. We're going to use it first of all to find factors of an equation and to find rational solutions of an equation. So we're going to use it a few different ways. Okay? If something is a factor, it divides into the polynomial evenly with no remainder. Okay? So real simply I could say 4 is a factor of 12 because 4 divides evenly with no remainder. Okay? So for something to be a factor, there's no remainder. Okay? So the same would be true with a polynomial. If it's a factor, it can divide with no remainder. Okay? If something is the solution of an equation, then the equation would equal 0 when the solution is plugged into the equation. Or the remainder would be 0 because we're going to use synthetic division. So if something is a solution, then if you took that x, or you took that number and you plugged it in everywhere in the equation, you should get a 0 at the end. Okay, so we've solved before where we've taken numbers and we've plugged them back in. And if we had an equation equal to 0, then we could take our answer, plug it back in, and we should get 0. Okay? I'm going to be using some different terminology here, just so you're kind of used to different words. Solutions are also called roots. Solutions are also called zeros of the polynomial. So when you hear the words solutions or roots or zeros, it all means the same thing. So don't let the terminology throw you off, okay? So we're going to use synthetic division and the rational zero theorem to answer the following questions. So I have a variety of questions. Some of them are worded differently, but you kind of do the same thing. And for all of them, we're going to use synthetic division, okay? So first of all, I want to know, given the polynomial x to the third plus 6x squared plus 3x minus 10 equals 0, determine if negative 5 is a root. So remember, root, solution, and 0 all mean the same thing. So one way to do that would be to take negative 5 and put it everywhere there's an x and then calculate that, okay? But I'm asking you to do it using synthetic division, okay? So we set up our synthetic division like we did in Goal 6.4. Nothing's missing. I gotta have my third, my second, my x to the first, and my constant. And then they want to know if negative 5 is a root. So that means in the box over here, I'm going to use negative 5. So you don't do any sign changes. You use the number they're asking you about. And I divide synthetically. So my 1 comes down, and then I multiply, and I add, and I multiply, and I add, and I multiply, and I add. I got a remainder of 0. So this is using the rational zero theorem here too, that if you get a remainder of 0, then it's a solution. It's a root. It's a 0. So the answer to this one is yes. You don't have to write that in any way, because this is a simple yes-no question. So because my remainder was 0, this is the only place I got to look to answer this question. Because my remainder is 0, my answer is yes. Same kind of question, just used a different word at the end. So given, and I should have had a space there, sorry, 3x to the fourth plus 2x to the third minus x to the second plus 5x minus 4 equals 0, determine if 1 is a solution. So again, we're going to set this up synthetically. They're looking to see if 1 is a solution. Do not do any sign changes. So 3 and 2 and negative 1 and 5 and negative 4. Am I missing anything? 4, 3, 2, 1, none. Nope. So don't forget to fill zeros in when you're dividing using synthetic division if you need to. So my 3 comes down below the line, and I multiply and add and multiply and add and multiply and add and multiply and add. And all I do is look at the remainder. Since there is a remainder, it doesn't come out 0. If there's a remainder, then 1 is not a solution. Okay? Okay, questions on that so far? All right, so given that f of x, now this is a different kind of notation. So instead of saying y equals, f of x is another kind of notation to let you know that we're working with a function. And we're going to do some more with that actually for the rest of the semester. That notation is going to pop up periodically. So f of x is the same thing as saying y equals. So don't let the notation throw you off, okay? So given f of x equals x to the third minus 4x squared minus 7x plus 10, determine if x minus 1 is a factor. So does x minus 1 divide evenly into the polynomial with no remainder? Because to be a factor, there should be no remainder. Like I said earlier, 4 is a factor of 12. 7 is not a factor of 25. There would be a remainder, okay? So if I want to determine if x minus 1 is a factor, again, using synthetic division, I set it up. So 1, negative 4, negative 7, positive 10. Now be careful here. We're working with the factor now. If x minus 1 is the factor, then the root would be the positive 1, like we did in Goal 6.4. When we did the division by the polynomial in the form x plus or minus n, we had to change that sign. So when it said minus 1, we had to change it to positive 1. Okay? So when you're working with the polynomial, yeah, then we got to do our sign changes. Okay? All right, so we're going to determine if this is a factor. We can use synthetic division to divide it in. 1 comes below, first number comes below the line, and then we multiply, add, multiply, add, multiply, add. So we get a remainder of 0. So since we get a remainder of 0, that means it divided evenly, no remainder. So yes, x minus 1 is a factor. Okay, so another one similar to that. I just used a different notation. On that first one, I used an f of x equals, and on this one, I'm using a y equals. But it's the same thing. Okay, so know that. So again, I set my synthetic division up. 2, 7, negative 7, negative 12. If I'm looking to see if x plus 3 is a factor, then my solution, my root, my 0 would be that negative 3. So 2 comes down, multiply, add, multiply, add, multiply, add. So again, I'm just looking at the remainder, and since it's not 0, then x plus 3 is not going to be a factor. Okay, so the first 4, more on the simple side. We're going to do synthetic division. We're going to look at the remainder. If it's a 0, my answer is yes. If it's not a 0, my answer was no. Okay? All right, again, we're using synthetic division, the rational zero theorem, to answer all these questions. Okay? So given f of x equals x to the third plus 10x squared plus 31x plus 30, and that x plus 3 is one of the factors, find the other factors. So back to when we actually did factoring, okay? The factoring is quantities are polynomials. So x plus 3 is one of the factors, okay? So we're going to set up synthetic division again. Now, I know I'm going to get a remainder of 0 because they told me that x plus 3 is a factor. And then that means in my box I put my negative 3. I'm going to have to get a remainder of 0 here. Otherwise, if I don't, then I messed up the question. Okay? So 1 comes below. I multiply. I add. I multiply. I add. I multiply. I add. All right. So think back to what we did in Goal 6.4 when we actually just divided the polynomial and we got an answer of, let's just say, x squared plus 7x plus 12 plus 2 over x minus 1. Okay? We divided and we got a polynomial answer. Well, we just divided x plus 3 into this polynomial and we got this answer. Okay? So remember that this was the remainder that we knew would be 0. This is the constant, this is the x, this is the x squared. So when I divide that polynomial by x plus 3, I end up with x squared, plus 7x plus 10. So that's kind of like back to what you did in Goal 6.4. Then you take that and you set it equal to 0 and you factor it. Actually, you don't really have to set it equal to 0. Special effects today. So x times x, positive and positive, and 5 times 2 is my 10, and also gives me my 7 in the middle. So when I divide my x plus 3 into the polynomial, using synthetic division, I get this polynomial. I take that polynomial and I factor it, and then those are my other two factors. That's my answers. X plus 2 and x plus 5. Those are the other two factors then. Okay, let's do another one like that. Given y equals, and again, f of x, y equals, same thing. Let's set up my synthetic division. 3, negative 7, negative 22, positive 8. X minus 4 is one of the factors, which means 4 is the root or the solution or the 0. So in the box goes positive 4. So my 3 comes down, and then I multiply and add and multiply and add and multiply and add. And again, I knew I was going to get a remainder of 0 because I said it was a factor. You have to get a remainder of 0 then. Then I take my polynomial that I have left, and I write that and I factor it. So I have 3x squared plus 5x minus 2. And I factor 3x times 1x. I think my plus is going to be over here. Yep. Positive and a negative. 2 times 1 is 2. Make sure you place that correctly because you want to get that positive 5. So outers, 6 minus 1 gives me my 5. So my other factors are 3x minus 1 and x plus 2.